Alright, so today we did analyzing graphs on the 9th. Okay, so analyzing graphs, the first thing we did was actually roughly graph a function when given a function f of x. So in order to do that, when given f of x equaling 3 minus x squared, let's find the x-intercepts so that we can plot those. Okay, to find x and y intercepts, we're going to set them equal to 0, right? So let's do x-int first. So we set y equal to 0, and we get 0 equals 3 minus x squared. We get x squared equals 3, so x equals plus and minus the square root of 3. So I have no room, sorry guys, but my x-intercepts are square root 3, comma 0, and negative square root 3, comma 0. Okay, so then my y-intercepts, we go ahead and plug in 0 for x. So y-int, we have y equaling, right, f of x is just another way to say y, 3 minus 0 squared. So y equals 3, so my y-int is 0, comma 3. So I'm going to go ahead, roughly graph that. Oh, this is going up by, okay, so 2, 3 is my y-int, and then square root of 3, I don't even know what that would be. Let's just call this the square root of 3, okay? Negative root 3 and root 3. Okay? And then we can go ahead and connect those. It's going to be an upside down parabola. Okay, graphed it. Check. Find the domain and range. So my domain is my x values. So moving along left to right, the x axis, okay? If we continued to take this parabola to negative infinity, it is continuously, slowly moving in the more negative direction, right? Same with this way. So looking left to right, eventually this graph right here is going to touch all x values, okay? It's just going to keep expanding until we hit all the x values, right? So our domain is negative infinity to infinity, and our range is our y values, which is up and down. Okay, we're going to continue going down forever, right? So we can have negative infinity on our, right, we always start lowest to highest. So negative infinity, and we top out at our y-intercept right here of y equaling 3. So this should be a bracket, sorry, because it does touch 3. Okay, so that's the highest we'll go in the y direction. End behavior, also known as function behavior, is what is happening to the y values as you move along the x-axis. Okay, so are they increasing, decreasing, increase, decrease? Like, what are they doing, okay? So, looking at this graph, from negative infinity to 0, sorry guys, got a phone call. All right, so from negative infinity over here, to 0 over here. So we're going across the y-axis, but we're looking at the y-axis. So at 0, we top out, right? So from negative infinity to 0, we're increasing. And then we top out and we start decreasing, right, from 0 to positive infinity. So from 0 to positive infinity, we are decreasing. Okay. Relative minima is locations on your graph that go from decreasing to increasing, okay? Or the graph starts to just top out and stay consistent. So it's a low on your graph, okay? So going from decreasing to increasing is going to look something like this, and this would be a relative min. Yes, you can have more than one. In this graph, we have no relative mins. Okay, because there's nowhere that this graph goes from decreasing to increasing and has like a valley shape. Okay, and then relative maxima is locations where your graph go from increasing to decreasing, or there's a high. So it's increasing, increasing, and then it starts decreasing, and this is a relative max. So looking at this graph right here again, we have a relative max at the point 0, 3. Okay, so at 0, 3, we have a rel max. Okay, so using the graph of f of x equal to 3 minus x squared, determine end behavior and relative maxes and mins, which is exactly what we just did, so I'm going to skip. Alright, so now let's do a different example. Using f of x equal to the square root of 10 minus x, find the x and y intercepts. So once again, we set 0 in for x, so x int would be 0 equaling square root of 10 minus x squared. You guys should know how to do this right now. We get plus and minus the square root of 10. So our x-intercepts are square root 10 comma 0, negative square root 10 comma 0. So let's just say that's here, square root 10, negative square root 10. Okay, and our y-intercept, we go ahead and make x 0. I'm going to pretend like I worked that out. I know you guys know how to do this. Our y-intercept is also square root of 10. So we can go ahead and graph that here. And connect our lines. Our points, sorry. So this is a pretty similar looking graph to the last one. Our domain, our x values are still negative infinity to infinity. Our range is from negative infinity to square root 10. Our end behavior, so from negative square root 10 to 0, hang on, was definitely trying to go too fast. Our function needs to stop at these points. I was like, this is way too similar to the other one. Since we have a square root, we cannot enter negative values. So our domain is actually, good thing I wrote in pencil, negative root 10 to positive root 10. Those are our x values. Our range is from 0 to root 10. Okay. Our end behavior from negative root 10 to 0, both with brackets, we are increasing, and from 0 to square root 10, we are decreasing. Okay, increasing, 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 decreasing. we have a relative max at square root of 10. Okay, and I would like you to write it in ordered pair. And we have two relative mins here. So before our function continued on forever, that's why we had no relative mins. Now our graph stops here at these minimum values. So relative mins at square root 10 comma 0 and negative square root 10 comma 0. Alright, so real quick, I just wanted to go over this crazy example. So determining the end behavior, I'm going to do the end behavior down here because we need some room. From negative infinity to negative 1, we are decreasing. Okay? From negative infinity to negative 1, our graph was decreasing. From negative 1 to 3, negative 1 to 3, we were constant. Yes, you can be constant. From 3 to 5, we're increasing. From 5 to 6, we are decreasing. And from 6 to infinity, we are increasing. So we have relative, I'm going to start with relative max, right? This is where our graph tops out at 5, 5. And we have three relative mins. Okay, so obviously this is a relative min. These are at the same y value, right? And they have they remain constant here, and it went from decreasing to constant to increasing. So this is a min between these two pieces of our function. So our relative mins are at negative 1, 2, and 3, 2, and 6, 0.